Welcome, Professor Emanuel. Welcome to Perugia. Welcome to Vitality Project. And first of all, could you explain to our audience, in particular, which field you are on?
So I'm very broadly an atmospheric scientist, a scientist who studies the behavior of the atmosphere. And I'm also very interested in the Earth's climate. I specialize in the weather of the tropics, and especially of hurricanes. So I spent a good part of my career studying hurricanes. And it's a really fascinating field. Scientists are motivated by curiosity. We want to know what's out there and why. And it's been a very satisfying career for me.
The whole world is probably asking, is the climate really changing? And so what's your point of view on that?
Well, we have enough information now from observations, from theory and models to know that yes, the climate is changing by geological standards extraordinarily rapidly, and that we are the cause of that change. There are all kinds of different ways we know that. First of all, we've been measuring fairly accurately the surface temperature of the planet since the late 19th century. It has clearly been going up and more rapidly in recent decades. The carbon dioxide content of the atmosphere, carbon dioxide being the most important long-lived greenhouse gas, has been going up, but it is not just the coincidence of those two. We've known since the end of the 19th century already that putting more greenhouse gas in the atmosphere will cause the climate to warm. We also know that the carbon dioxide that's been put in the atmosphere came from us because of its particular isotopic or chemical composition. So all the pieces fit together, our theory, our models, and observations. So clearly we are changing the climate to a warmer climate. And I want to say something important to set that in context. So many viewers will know that the Earth's climate on longer timescales have changed rather dramatically. 20,000 years ago, most of Northern Europe was under a kilometer or more of ice. And in fact, there have been 10 ice ages over the last 3 million years or so. And that's a lot of climate change, but it took thousands and thousands of years. We know why the climate has changed on those timescales. It's because of small but very predictable variations in the Earth's rotation around its axis and its orbit around the sun. So there's been a lot of really fascinating climate science that's been done that has nothing to do directly with global warming. But the warming I'm talking about is on a much shorter time scale, it's 100 years. The important thing to understand is that while human beings have been around for 200,000 years, it's only in the last 6,000 or 7,000 years that we settled down and started to farm and to keep animals, cattle, for example. And that is generally what we think of as the dawn of civilization. And civilization developed only when the climate stabilized at the end of the last ice age. So the important point is that we human beings, civilization, is very finely adapted to an almost uniquely stable climate we've enjoyed for the last 7,000 years. If you change that, it doesn't even matter whether you warm the climate or cool it. If you change it, it disrupts us very much, and that's a problem for humanity.
How can we face such complex problems? I mean, you, as a scientist of the climate, are facing maybe the complexity every day. So how can we do?
Well, there's a scientific question of how do we understand a complex system? And that's what makes climate science so fascinating. And do we know everything? No, almost never in science do we know everything, but we're making very good progress. We know enough to know that we're putting civilization at risk. And that risk doesn't come from the fact that the temperature is a little higher. You know, if you live in Northern Europe, maybe it's good for the temperature to be a little bit higher. That isn't the problem. The problem is sea level. Some of our coastal cities are, again, very finely adapted to stable sea level. Turn the clock back 20,000 years to the middle of the last ice age, sea level was 120 meters lower. Now, if that happened today, it would be catastrophic. Port cities would be high and dry. So this is an illustration of how finely we're adapted to the situation. So sea level rise eventually will start flooding. It's already starting to happen in some places, but start flooding seaports. But besides that, it's the extreme weather events. And when you study climate science, you understand that the extreme events are the canary in the mine for climate change. They change much more rapidly than the normal state of the climate. So we expect to see much more intense hurricanes, and we are seeing, the satellite data is unequivocal, we are seeing more intense hurricanes, more wildfires, more drought, and ironically, more floods at the same time. That sounds like a contradiction, but it isn't. Climate science actually predicted that. The problem with the droughts and the floods is it destabilizes our agricultural system and it causes shortages of food and water, and we know historically that that often leads to armed conflict. So the choice for humanity is either to make really strident and expensive and only partially successful efforts to adapt to the climate change. And the other thing we can do is to try to prevent more of it by switching our energy sources away from carbon. And possibly, although it's too expensive now to extract carbon dioxide artificially from the atmosphere. Those are really the three options ahead. In practice, it will have to be a combination of those things. I'm pretty optimistic about that. I look back at history, and not so long ago, in the 1970s, there was a war in the Middle East, and that resulted in chronic fuel shortages in the civilized world, North America, Europe, and so forth. And countries responded remarkably quickly to that, not from the point of view of climate, but for energy security. So within 12 years, Switzerland and France and Sweden, just to take three examples, completely decarbonized their electricity. Now, they did that with hydro and nuclear power back in those days, but the point is they did it, right? We've already done the experiment. We know we can do it. What's changed now? The fossil fuel companies are much more powerful, they're much more politically connected and so forth. Nuclear has become, in my opinion, artificially much too expensive, and we need to make it cheaper again. It started out very cheap. But we also have solar and wind now, which are much cheaper than they used to be. So some combination of these carbon-free energy sources, even today, is doable. And if we did it in 12 years back in the 70s, on paper, we could do it again. So I'm optimistic that we will, and I hope there's not too much suffering in the meantime.
Okay. Thank you, Professor, for sharing with us your thoughts and your vision about our destiny, in a sense. And enjoy your stay in Perugia these days. Thank you very much.
Thank you very much. Yeah.